Myself, Jayshree Shedbalkar, welcomes you for the lecture series on computer graphics and visualization. The main purpose of studying this subject is to have the knowledge of various techniques used for application programming. Computer animated movies have provided to be commercial and artistic successes. The use of computer effects in movies is standard and it is often almost impossible to distinguish live action from computer generated effects. So a top-down approach using OpenGL resolved most of the difficulties experienced with other APIs and with the alternative of using home-brewed software. So OpenGL is going to support on all the platforms and made very easier to understand key graphics topics including 3D graphics, lighting, shading, client server packages, modeling and implementation of algorithms. And this is very helpful and have a stronger foundation for both theoretical and practical aspects. In this course, programming deals with both the C and C++ as the dominant languages and the many application areas like filmmaking, generating graphical displays of very virtual environment in real time, banking, education, training the pilots with simulated airplanes and full feature length of computer animated movies. This subject can be useful for computer science and engineering students. In the other disciplines, those who have good programming skills. An object-oriented approach and benefit from the use of C++ for the computer graphics applications. This subject requires the student to know about the basics of computer graphics applications using top-down approach using OpenGL. With good programming skills in C or C++ and understanding the basic data structure and linear algebra and geometry required for fundamental of computer graphics. So this can be both informative and fun. OpenGL remains standard programmer's interface both for writing application programs and developing high-level products. So this is what about the overview of the course and the prerequisites required to have into the course. Now let us move to the lecture series on the computer graphics and application with the module number 1 and the first lecture. So today we are going to cover about what basics of computer graphics, what are all the advantages of computer graphics and its applications, and what is the graphics hardware required to support this graphics. So with this you will be able to understand the overview and the basics knowledge of the computer graphics. Now let us move to the first module, that is overview of graphics. What do you mean by graphics? Graphics stands as the products of graphic arts, especially in commercial design or illustration. Normally graph means which is going to have the pictures or graphical arts. So the use of diagrams in calculation and design. So this is what actually the meaning of graphics. So which is able to produce some graphical arts and it is going to produce some diagrams related with some calculation as well as with a design. So now if we relate this computer architecture or computer graphics with the drawing of the graphical arts as well as some diagrams related with a computer. So now these diagrams if we draw in with the help of computer, that is what is called as computer graphics. Means computer graphics are pictures, not only the pictures which is going to have the films. Films means some dynamic movies or the mood pictures. So created by using the computers. That is what is called as computer graphics. Usually this term refers to computer generated image. Computer generated image are synthetic images. And these data, the image is created with the help from the specialized graphical hardware and software. So to create with these computer graphical images, it is necessary to have some specialized software as well as some hardware, and it is very responsible for displaying art and image data effectively, and it is going to give or send the meaning to the user very effectively. So what the actually art or picture is going to tell, what is the concept, it is going to tell to the user very meaningful. So it is also used for processing image data received from the physical world. So physical world, whatever the images we are going to see, for example say building, trees, any type of physical world, what are all the entities we are going to have in our day-to-day life. So all those things will be received and that thing will be processed and it will be converted into computer generated images. So the computer graphic development had a significant impact on many types of media, which has taken a revolutionized in various areas such as animation, movies, advertising, video games and graphic design generally. So the computer graphics can be more precisely defined as, these are the visual representation of data which is going to be displayed on the monitor made on a computer. Computer graphics can be a series of images. Series of images is also called as video or a single image. So normally this is going to be considered as visual representation of data onto the monitor. The computer graphics are very useful and these are computer generated images used for movie making, video games or some computer program development, scientific modeling, design of advertising and other commercial art, and even some people are going to make the use of computer graphics as an art also. So this is what about the computer graphics and where actually normally we come across with this computer graphics. Computer graphics can be of two types. It can be of two-dimensional or three-dimensional, and they are made differently and used differently. People use different computer programs to make different types of graphics. In two-dimensional computer graphics, this will be usually split into two categories, that is vector graphics and raster graphics. So now we'll move to these two types of graphics. Vector graphics use lines, shapes and text to create more complex image. If a vector graphic image is made very big on a monitor, it will be still be good as it's with its regular size. This is the one of the reason vector graphics are liked so much. Vector graphics are drawn. These are the some graphics images you can see in this diagram. These are the some graphic images which are only drawn with the help of some lines. You can see this is what the outline. Lines, some curves, some shapes. So this is also lines, curves, shapes. So if the graphic or picture is drawn with the help of lines or shapes or some text, so that type of graphics is what is called is vector graphics. Vector indicates it is a line. So with the name of this type of a graphics, we can easily remember how the vector graphics can be drawn with the help of lines and shapes. Now another type of graphics is raster graphics. So raster graph, instead of using the lines and shapes, the raster graphics use pixels. Pixels to make up a larger image. So this doesn't mean that artist has to change a single pixel at a time, but the raster programs often have the tools like paint brushes. I think you have used paint, how actually the paint can be drawn using the paint with the help of some erasers, lines or paint brushes, paint buckets, so that which is going to able to fill that particular color onto the shape. Means so that part of the pixels has been assigned with some color, or else it can be, if you want to erase that, with the help of some erasers also we can erase the pixels or whatever it is being done onto the monitor. So this is how actually the raster graphics can takes place. And even some programs are also written, and some of the software also are there, such as Adobe Photoshop, Corel Paint, Shop Pro. So these are some of the applications, apps directly we can use, or often it can be used as a part what the user sees and when she uses to a computer program. So here it is, you can see easily. So this is what the figure of rows. So which is able to distinguish the two parts of the figure, that is the background of the figure and this is the foreground. Foreground which is going to focus on the rose flower. This is what the structure of the rose, and the background color is maybe something like leaves and all. So this is how exactly it is going to divide the scene into foreground and background color. Compared to the vector graphics, raster graphics is going to generate a realistic scene. So if you compare with the vector graphics, which is not able to produce that much realistic scene, but the raster graphics is going to produce the realistic scene of the physical world. Now another type of graphics is three-dimensional graphics. Three-dimensional graphics are the graphics that are going to look like objects. Even they are going to look like a object. So this is one picture movie, Elephant's Dream, which was made with a blender. This was one software which is able to create a movie in it has been created with a movie called Elephant's Dream. So this is a 3D movie which has it is going to look like a object, and these are going to be operated on 3-dimensional, which means the computer thinks that it has height, length and depth. But if you compare with the 2D graphics, only it has a height and length but not the depth information. So in 3-dimensional graphics, which includes the depth information into it, so that effect will be more realistic and it is going to display them as it is. And in 3D graphics are used many times in movies and TV shows as well as some video games. Even I think you might have come across with some of the video games. So those can be played as a realistic games. So this is another type of graphics, 3D graphics, which includes the height, length and the depth. Now let us move to the basics of computer graphics. So computer graphics is an art of producing pictures or drawing pictures, lines, charts, etc. using computers with the help of programming. So now here we are going to learn about some programming concept to produce the picture or draw the picture. Even we can draw the lines, animations, movies. So that thing can be done with the help of some computers. So computer graphics image is made of number of pixels, and pixel is the smallest addressable graphical unit represented on the screen. So pixel is considered as smallest addressable graphical unit. So this addressable graphical unit is what is called as the very important thing. That thing will be considered for computer graphics. And computer graphics is a combination of number of pixels. That we think we have discussed now just now about in raster graphics. So which is able to differentiate between the foreground as well as the background. So that thing can be easily produced with the help of the number of pixels. Now let us move to the advantages, where actually we come across and what are all the advantages of computer graphics. Computer graphics is very effective and very commonly used way of communication with a computer. So whatever the thing we want to communicate with a computer, either we are going to send some instructions to the computer so that which is able to draw that particular image. So that communication will happen between the user and the computer. And it also provides producing the picture in the form of real world. And whatever the real world picture is there, so that is going to be created in the form of synthetic objects such as some mathematical surfaces in 4 dimensions and the data that have no inherent geometry. And it has the ability to show moving pictures, thus possible to produce some animations with the help of some computer graphics. With the use of computer graphics, we can control the animation by adjusting the speed, portion of picture in view, the amount of detail shown and so on. And it also provides tools called motion dynamics in which the user can move the objects as well as observe as per requirement. For example, walkthrough made by builder to show flat interior and surroundings. It also provides the facility called some update dynamics so that we can change the shape and color of other objects and properties of the other objects. And in recent development, we might have come across with the digital signal processing with some audio synthesis chip and some interactive graphics, which is going to provide the audio feedback along with the graphical feedbacks. Now let us move to the applications of computer graphics. First one is about the user interface. User interface means, so this is the interaction between the user and the computer. So that thing can be easily done with the help of some graphical user interfaces. So that the visual object which we observe on the screen and whatever the communication with the user with the computer, that can be done very easily with the help of some useful applications by the computer graphics. So computer graphics helps us to design some graphical user interfaces so that the user interface can happen interactively. Next one is about plotting of graphics and chart. In industry, business, government and the educational organization, drawings like some bars, pie charts, histograms, and these are very easily understandable for good decision making and very useful for quick and good decision making related with any of the educational or organizations. Next one is about the office automation and desktop publishing. So this is used for creation and dissemination of information. It is used in house creation and printing of the documents which contain some text, table, graphs and other forms of drawn or scanned images or a picture. The fourth one is CAD applications, computer aided drafting and design. So in this graphics can be used to design some components and systems such as automobile body structures of building, etc. Next one is about the simulation and animation. So in the graphics or with the use of graphics, it is very easy to generate the simulation which makes the some mathematical models as for mechanical systems to more realistic and for easy to study. Next is about the art and commerce. The computer can also be used generally in arts and commerce, which consist of many of the tools provided by graphics, which allows the user to make their picture animated and attracted, and that can be used for advertising. Next is the process control. So nowadays automation is used with the graphically displayed on the screen. So whatever the process automation what happens in the computer, that thing can be controlled and all the processes will be controlled using the computer graphics. The next application of the computer graphics is cartography. So cartography is a study of some maps, geographical maps and weather maps or some oceanographic charts and all. So even computer graphics is also used to represent these type of maps such as geographic maps and weather maps and oceanographic charts. And next about the application of the computer graphics is education and training. Computer graphics can be used to generate models by physical and financial and economic systems. These models can be used as educational aids. And next application of the computer graphics is image processing. Again, this is a very vast area in the computer graphics, which is used to separate or changing or process the image by changing some property of the image. In this area also the wide application of the computer graphics. The next is about the photo enhancement, so that whatever some blurred images are there, so even that blurred images can also be considered or to be made with the help of some sharpening the blurred images with the help of some softwares. That thing can be done with some photo enhancement, and also used in some medical related applications such as medical imaging. In medical images, some MRI images, CAT scans, etc., and some non-invasive internal examinations. So in these areas also normally the computer graphics can be used in vast. So these are the 12 application areas where we come across with the use of the computer graphics. So entertainment can be considered either with the help of some games or movies. Training, educational and training can be done with the help of flight simulators, some computer aided instructions, etc. And architecture related with the construction plans such as building plans, exterior sketches or some blueprints. Even that blueprints can be replaced with some hand drawings of the past. So all these architecture related thing can be done, and also some business presentation graphics. So business presentation graphics, what we can say is a worth slogan of a picture is worth than 1,000 words. So now we'll move to the computer graphics hardware. What is the necessity thing or hardware part related with the computer graphics? The main hardware part required for computer graphics is video display devices. Video display devices means the monitor, display devices, any display devices. So because the primary output, whatever we are going to see as an image or as an art, as an application, everything should be displayed with the help of monitor. So the primary output device in computer graphics is monitor or video monitor. Historically, the operations of most video monitors was based on the standard. So for that cathode ray tube CRT design, but with some several technologies also exist. In recent years, so many video display devices have come across with flat panel displays and have become nowadays very significantly more popular due to their power consumption and thinner in design. And this type of display is called refresh CRT, that is cathode ray tube, and the frequency at which a picture is redrawn on the screen is called as refresh rate. So these are the terms, normally refreshing CRT or refresh rate. How many times a picture is redrawn on the screen, that thing will be called as a refresh rate. So the basic design of the cathode ray tube, that is what the refresh cathode ray tube, this is what the basic design of a magnetic deflection of CRT, which consists of some connector pins will be connected to the base and one electron gun which is producing the electrons, and those electron of beams will be passed through the focusing system depending upon the horizontal and the vertical deflection among the focusing system, and that ray is going to come and with the help of, and that thing will be controlled with the help of some magnetic deflection coils, and the particular ray which is going to come and hit onto the phosphor coated screen. So this is what the phosphor coated screen, and which is able to produce a point or illuminated point onto the phosphor coated screen. So this electron beam once come and hits onto the phosphor coated screen, and that particular point will be get illuminated. Like that, the so many number of electron gun is going to produce the many number of electron beams, and that thing will be controlled with this type of focusing system and the deflection coils, and yeah, all the electron guns are going to hit onto the phosphor coated screen. Once they are going to hit onto the phosphor coated screen, which is able to produce the on and off of the illumination. So if it get illuminated, that is what is the pixel is will be get illuminated, or else it will be in a off condition. So this is what the basic design of magnetic deflection CRT. So this is explained as the beam of electrons, or sometimes called as cathode rays, emitted by an electron gun, just now we have seen in the diagram, which passes through the focusing system and the deflection system and direct the beam towards the specified positions on the phosphor coated screen. The phosphor then emits all small spot of light at each position contacted by the electron beam. So which is going to emit a small spot of light each position where it is going to come contact with the electron beam. Because the light emitted by the phosphor fades very rapidly, some method is needed for maintaining the screen picture. So whatever the light emitted by the phosphor is going to fade very rapidly. Because of that, it needs to maintain the picture always. So one way to do this is to store the picture information and charge the distribution within the CRT. So this charge distribution can then be used to keep the phosphors always activated. So the most common method now employed for maintaining the phosphor glow as well as to redraw the picture repeatedly by quickly the direction of the electron beam back over the same screen points. And this is what the operation of an electron gun with an accelerating anode. So whatever the focusing anode is there, so that thing will be normally controlled with the help of control grid. And in the control grid, there will be a heating filament and which is able to produce the heat produced by, so that the cathode rays are going to produce the electron beams, and those beams are going to pass to the focusing anode. So this focusing anode and the accelerating anode which is going to form or decide the electron beam path, so that that particular beam path is going to hit onto the phosphor coated screen and that will be get illuminated. So therefore, some primary components of an electron gun in a CRT are some heated metal cathode, and that cathode is going to be controlled with the control grade heat, and that heat will be supplied to the cathode ray and which is going to direct the current through a coil of wire called the filament inside the cylindrical cathode ray structure. So which is going to cause the electrons to be boiled off. So it will be get hot and it is going to be produce the electrons, and those electrons will be boiled off and those are going to be moving to inside the vacuum inside of the CRT envelope, and the free negatively charged electrons are then accelerated towards the phosphor coating of by a high positive voltage, so that the accelerating voltage is to be generated with the positively charged metal coating on the inside of the CRT envelope near to the phosphor screens or with the accelerating anode. That what we have seen in the figure, and can be used to provide some positive voltage. Sometimes the electron gun is also designed so that the accelerating anode and focusing system are within the same unit. And very important thing about the electron gun beam is intensity. So that intensity of the electron beam is controlled by the voltage at the control grade, and which is a metal cylinder which is going to fit over the cathode. The high negative voltage applied to the control grade which is going to shut off the beam and repels the electron and stopping them from passing through the small hole at the end of the control grid structure. And some smaller negative voltages on the control grid simply decreases the number of electrons passing through it. Since the amount of the light emitted by the phosphor coating depends on the number of electrons striking the screen, and depending upon that, the brightness of the display point is controlled by varying the voltage of the control grid, and this brightness is what is called is the intensity level and is specified for individual screen positions with the graphics software command. The focusing system in a CRT is going to focus on the some electron beam, and that is going to converge with some small cross section as it is going to strike onto the phosphor. These electrons are going to repel each other and the beam is going to produce, and which is going to spread across with the screen, and it is going to approach the screen, which is going to be accomplished. This focusing system is going to be accomplished with either the magnetic fields or with some electric fields generated, and this electromagnetic or electrostatic focusing electron beam that will be passed through the positively charged metal cylinder, so that the electrons along with the center line of the cylinder are in a equilibrium position. This arrangement forms an electrostatic lens, so which is able to produce the focusing at the center of the screen with the help of some lens. That optical lens focuses a beam of light with some focal distance. Similarly, that focusing effects can be accomplished with the magnetic field set up by a coil mounted around the outside of the CRT envelope. And that magnetic lens focusing usually produces a small spot size onto the screen. So additional focusing hardware is also used for high precision systems or to keep the beam in focus at all screen positions. So that and this will be depending on the distance of the electron beam and with what intensity it is going to be travel with different points onto the screen. And depending upon this distance and the intensity, the screen varies because of the radius of the curvature, and the most of the CRTs are greater in distance from the focusing system to the screen center. Therefore, which is going to produce the electron beam, and that is going to be focused properly only at the center of the screen. So as the beam moves outer the edges of the screen and the display becomes normally blurred. To compensate for this, the system can adjust the focusing according to the screen positions of the beam, so that which is able to produce the image with the same intensity with all areas of the screen. The deflection of that electron beam can be controlled with the magnetic fields or the electric fields, and the CRT tubes are now some commonly constructed with magnetic deflection coils mounted on the outside of the CRT envelope. There are two types of pairs of coils which are used for this purpose. One pair is mounted on the top and other one is at the bottom of the CRT neck, and the other pair is mounted on the opposite sides of the neck, so that the magnetic field produced by each of the pair of coils, which is going to reduce result in a transverse of a deflection force that is perpendicular to both the direction of the magnetic field and the direction of the travel of the electron beam. Horizontal deflection is accomplished with one pair of coils and the vertical deflection with the other pair. And the proper deflection amounts are attained by adjusting some current through the coils. When electrostatic deflection is used, two pairs of parallel plates are mounted inside the CRT envelope, and one pair of plate is mounted horizontally to control the vertical deflection, and the other pair is mounted vertically to control the horizontal deflection. So this is what the electrostatic deflection of the electron beams. So these are the connector pins. Base will be mounted with the electron gun. That thing will be handled with the focusing system, and this thing will be controlled by the horizontal deflection plates and the vertical deflection plates. So which is able to consider the deflection of the electron beams to be handled, and normally going to come with the contact with the phosphor coated screen with all the areas. And whatever the spot of light are going to be produced on the screen by the transfer of the CRT beam, and which is going to generate a energy, and that energy is going to hit onto the phosphor. So wherever it is going to hit onto the phosphor, which is that beam is going to collide with the phosphor coating, and these are going to be stopped with their kinetic energy, which is absorbed by the phosphor. And the part of the beam energy will be converted by friction into a heat energy, and the remainder causes the electrons in the phosphor atoms to move up to higher quantum energy levels. After a short time, the excited phosphor electrons begin dropping back to their stable ground state, and which is going to give up their extra energy as small quantums of light energy called photons. And what we are going to see on the screen is combined effect of the electron light emissions and that is going to glow like a spot, and which is going to quickly fade after the excited phosphor, and electrons are returned to their ground energy level. And whatever the frequency is considered, that is normally depicted with the help of some color components or the color of the light emitted by the phosphor. And this color emitted will be normally considered with the primary colors such as red, green and blue, and that light, whatever the light or whatever the color is assigned with the frequency of that electron beam, and that light is going to be emitted by the phosphor in the proportion to the energy difference between the excited quantum state and to the ground state. There are different kinds of phosphors are available for the use in CRTs. Besides with the color, the major difference between phosphor is the persistence. That is, how long they continue to emit the light. That is, how long it is before all excited electrons have returned to the ground state after the CRT beam is removed. The persistency is defined as the time that it takes so that the emitted light from the screen to decay to 1/10 of its original intensity. Lower the persistence of the phosphors require the higher refresh rates to maintain a picture on the screen without flicker. A phosphor with low persistence can be useful for animation, while high persistence phosphors are better suited for displaying highly complex and static pictures. Although some phosphors have persistence values greater than 1, and second, general purpose graphics monitors are usually constructed with the persistence ranging from 10 to 60 microseconds. So this is how the intensity distribution of an illuminated phosphor spot on a CRT screen. At the center of the screen, the intensity will be very high. As it comes towards the edges of the monitor, the intensity level decreases on the left side also as well as onto the right side. So the only intensity will be very high at the middle of the screen. So this is what the intensity distribution of a spot on the screen. Intensity is greatest at the center of the spot and it decreases with a Gaussian distribution out to the edges of the spot. And this is going to correspond to the some cross-sectional electron density distribution of the CRT. And this will be depending upon the maximum number of points. If there are maximum number of points are there, and those things will be displayed without an overlap. So a CRT is referred as a resolution. More precise definition of a resolution is the number of points, how many number of spots or points are there per centimeter that can be plotted horizontally or vertically, horizontally and vertically. And this is often simply stated as the total number of points, the total number of spotted points in each direction, and the spot intensity has a Gaussian distribution. So these are the now two spot distributions. This is what the example, the two illuminated phosphor spots, and even these are distinguishable where there is a separation in greater than the diameter at which the spot intensity has fallen to 60% of maximum, so that the resolution of the screen can be maintained very easily, so that these two spots are so near that even they are not greater in the distance of that of the diameter. So nearly these two spots are kept, so that even with the help of naked eye we are unable to distinguish that there are two small points. So this is how the resolution can be considered and very important depending upon the screen. So those are the total number of points, how many number of points are there horizontally as well as vertically. So two adjacent spots will appear distinct. In the diagram you have seen that there were two spots and their intensity was overlapping. And the distinct as long as there are separation is greater than the diameter at which each spot has an intensity of about 60% of the center of the spot. So this is going to overlap the position. And spot size also depends on the intensity. As more number of electrons are accelerated towards the phosphor per second, and the diameter of the CRT beam and the illuminated spot also increase. So that if the increased excitation energy which is going to spread to the neighboring phosphor atoms, so that not directly in the path of the beam, and which further increases the spot diameter. Thus, the resolution of a CRT is dependent on the type of the phosphor. The intensity to be displayed on the focusing and deflection systems. Typically, resolution on high quality system is considered as 1280 pixels on the horizontal sides by 1024 pixels on the vertical. So, with the higher resolutions available on many of the systems. This is what the typical resolution on the high quality system. And the high resolution systems are often referred to as high definition systems. The physical size of the graphics monitor on the other hand is given as the length of the screen diagonal, and which is going to vary from about the 12 inches to 27 inches or even more. And the length of the graphics monitor will be normally considered, or it is going to be varied depending upon this length of the corner to this, that is top right of the corner to top left corner to the bottom right corner. So this is what the length will be measured from this particular point to this particular point. So that the CRT monitor can be attached to a variety of computer systems, so that the number of screen points even that can actually be plotted depending upon the capabilities of the system and the size of the monitor. With this, here we are going to end with the today's lecture. Today we have studied about the basics of computer graphics, advantages and the applications, and the computer graphics hardware. The main computer graphics hardware we have discussed today is about the video display devices. In that we have discussed about the CRT, cathode ray tube, with its intensity, resolution and persistence rate, and how actually this is going to support to the displaying of the picture, and the intensity level depending upon the intensity level. With this you will be able to understand what is the basics of a computer graphics and the hardware part required to understand the graphics related thing. The more important questions on this topic are: what is a computer graphics, and explain the applications of the computer graphics. Explain the basic operation of CRT with its primary components with neat diagram. And very importantly about these definitions of the terms like resolution, persistence, aspect ratio. Aspect ratio is the total number of pixels in the horizontal divided by the total number of pixels onto the vertical. Even that thing also can be considered as vice versa. And define the term pixel, that is a picture element. So these are the most commonly asked questions on this topic. For this lecture, you please refer the textbook 1, chapter 1, 1.1 to 1.10. Page numbers from 3 to 32. Thank you.